All right, guys, let's do a little review. What has happened so far is that you extracted your DNA, you purified it, and then you did a gel electrophoresis on it, and you verified that there was, in fact, DNA in your sample. Then you, quote unquote, but not really, had your DNA sent to a sequencing lab. And today you're supposed to get that DNA sequence back. And it was supposed to be the entire genome. But in actuality, you would not have done that. In actuality, you would have ran your gel electrophoresis to verify that there was indeed DNA there, but then you would have taken that and found a primer to isolate a specific gene of interest, then ran it through a PCR so that you can get several copies of that gene of interest, and then sent that sample, just the gene of interest sample, off to the sequencing lab to verify that it was in fact the bacteria that you thought it was. So, what I'm going to do today is we're going to be given that 16S rRNA, just two R's, 16S rRNA sequence that is the gene of interest. And what you're going to do is you're going to say, all right, let's back up and pretend that I'm going to make a primer to target this gene of interest. I'm going to make that primer, report the information on that primer today, and then I'm going to go back and use that 16S rRNA sequence that you quote unquote got back from the lab, but not really, right? But it's a fake lab. You got back the fake lab sequence today, and you're going to verify that that was indeed the sequence from the bacteria that you thought your unknown was. So that's a mouth load, but let's start by doing this. Let's open up a page just for the NCBI website where we'll start all this. So I'm going to type in NCBI and it's already there for me. Go to the page that is the main page and click on Blast. Once I'm on Blast, I'm going to scroll down to Primer Blast. And this is where I'm going to make my primer. My teacher's already given me my gene of interest, so I'm going to Control V, basically pasting it into the sequence there. You can leave this at 70 to 100, or sorry, 70 to 1000. And then I will scroll down and make sure that this says enable so that I get all the different type of primers for this. And then I say get primers. This may take a while. So while this is going on, I'm going to toggle over to another page. Actually, I could just say duplicate. All right, so now that I've got this page, I'm going to go to the main page by just clicking on the very top logo again, and then go to Blast yet again. And when I scroll down, now I'm going to go to nucleotide blast. What I'm going to do now is I'm just verifying that the sequence that I got back from the lab is in fact the bacteria that I thought it was. So I think it's Pseudomonas fluorescens, but let's be sure. So I'm going to control paste again, control V. And then I'm going to scroll down, and now it looks a little different, but that's okay because it's supposed to be. I'm going to make sure that my database that I select is this one that's in parentheses. It says RefSeq RNA. There's others that look like it, but we want the one that's in parentheses that says RefSeq RNA. And then I'm going to blast this one. While this is going on, it may take a while. I'm going to toggle back to where my primers are. So now I have several primers, and you'll want to check a few things and report a few things. So the very one at the first primer is usually the very best primer. So I'm going to report the forward and the reverse primer, and I'll jot that down. The product length is 382 base pairs, so I'll jot that down. And then I'll toggle over here and make sure that my GC content is within 40 to 60. If it's not within 40 to 60, it's not a good GC content. And so this one is within that range and it's good. So I've got a primer that I would have used to isolate that gene of interest, run a PCR on that to get several copies, and then that would have been sent to the lab so they can sequence it. I can verify my DNA sequence when it comes back. So now we're going to pretend. We're pretending that we got the sequence back after I've used this very primer right here and sent it off to the lab. Go toggle back. and I've dumped that sequence. Remember, I've dumped the sequence in and I blasted it, and I'm checking to see, do I see a Pseudomonas fluorescens anywhere here? And womp womp womp. I don't really see Pseudomonas fluorescens. I see Shigella, I see E. coli, I see several others. So I'm wrong. But what is my bacteria, you say? It looks like it's Eracia. I can't even pronounce this, Fergusoni. And so it's a high probability that it's Eracia Fergusonia. And that high probability is shown here with my percent identity right there. It's not the greatest percent identity, but it has a good query cover and it has a good E value. So that E value was telling me that the arrangement of my nucleotides, is there any other arrangement that could have been a higher probability of being anything other than what this is saying here? And if it's 0, that's good. If it's anything above 0.01, that's bad. So it's a high probability that my bacteria is this here, and I can even click on it, go to the accession number right here, which I need to report as well in my notes, and then click on the FASTA. And when I do that, it gives me this sequence. I can really just take this sequence right here and copy and paste it into a Word doc and check to see, is this the same sequence that I had? Okay, so that is what you will do today.